Now let's go over the basics of stack, and we are going to implement one later. So what is a stack? Stack is a ordered collection of elements that follow the last in, first out principle. So this is really important. This is pretty much what defines what stack is. So what does that mean? It means last item in the stack is the first one to be deleted. Stack performs insertion and deletion at the end of the stack only. Now think of stack of plates in the cafeteria, and when you take a plate out from a stack of plates, you will only take the top one, right? And if you were to put more plates into that stack, you wouldn't go all the way bottom and then hold all the stacks of plates and then put it on the bottom. You would just put it on the top. So that's what exactly what stack is. So let's say that we have our empty stack here, and let's say that we want to put in more elements. So we have 1 here, we have 2 here, and 3 here, and now we have only 3 elements in our stack. But if you were to take any one of these stacks or numbers out, we wouldn't go all the way to the bottom and then take this out. That's not what a stack is. Stack only takes elements out from the top of the stack, just like our plates. And that's what it means to follow a last in, first out principle. Well, 3 happened to be the element that was last added to our stack. So this one is going to be the first one to go. And then it was 2, right? After we get rid of 3, 2 is going to be the one to go. And then after that is going to be 1. So remember the principle last in, first out. Whatever we added recently, if we were to take any of them out, that one is going to go out first. Now here we are going to implement stack using object store our data, and we're going to use a constructor function. You could totally use class, but I want to show you guys a different example, and we are going to add our methods to our prototype of this function. Try to implement these methods. It should be really straightforward, probably easier than our array implementation and its methods that we did before. And this is our time complexity. Well, access is cheap, just like our arrays. As instant search is going to take O of n, and insertion and deletion is going to be O of 1. And the reason is because we are going to only insert and delete at the end of the stack only. Again, if we have a bunch of elements, we're not going to go in the middle of our stack and take this one out. And if we were to do that, we would have to reindex our elements 1, 2, 4, and 5. We are not going to do that. We are only going to take only the top element out, and then the next element, and then the next element, and so on and so forth. And space complexity is going to be O of n, where n represents the number of inputs. If you guys find this helpful, make sure you guys like and subscribe. Thanks. Now, first thing we want to do is we want to create our object constructor function. So this is the one that is going to create the stack object. Now, this one is going to have 2 properties, and one is going to be store, where we store our elements, and that's going to be an object literal. And next one is going to be the top property, where it tracks the number of elements in our stack, and it's going to refer to the top element, and we are going to set that equal to 0. So first thing is create a function, and we capitalize S, stack, and we give 2 properties, this dot store, and set it equal to an empty object. And we give our second property, which is going to be top, and set this equal to 0. Now let's try initializing our stack object. So we go all the way down here and create a new instance of our stack. So let's call it stack, and set this equal to new stack, and let's try printing it. And as you can see, we have our stack with our store and our top property. Now let's add our first method, which is going to be push. And when we add our method using constructor function, we have to add our methods under prototype. And I'll explain more about this after we code our solution. So this is going to be adding push method to our stack, and it's going to be a function, and we pass in a value, and let's get to our solution. So we want to add an element to the top of the stack. So that's going to be this dot store, and we pass in our index and set this equal to value, and we have to increment our length by 1, right, each time. But instead of doing this dot plus plus in the next line, you can just do it here. And if this is all too fast, make sure you guys watch the previous video because we went everything in detail. This is just a different way to do it. So let's just go down and see if our push method worked. So let's do stack.push 1. Let's copy this 2 times and then add in 2 more elements. And let's console log our stack. So we have our elements 1, 2, and 3, and our top is 3. And that's looking good. But going back to prototypes, we did say that when we are doing stack.prototype push, we're adding this push method to our stack object. But where do we see that method? So if we were to actually just console log stack.prototype, you can see that we have our method push here. So when we create a new object, when we create a new instance of our stack object, it comes along with these methods that we implement. So far we just implemented push, but as we implement more, it's going to be added onto that. And this new instance of stack is going to be able to access these methods that we implemented. So when we implemented our array using classes, what we did was technically we created, instead of a function, we did class and we passed in a constructor function. And then we just did push parentheses, open brackets. But for this method, using object constructor function, we have to pass in the methods under prototype. But you might ask, what's the difference? Well, there is actually no difference. The only difference is that when we use classes, we don't have to keep typing stack.prototype function, these keywords. It shortens everything out. So it's like shorter way to do the same thing. But under the hood, when we use classes, it's exactly just doing this. It's just a way to save us time by writing less stuff. Now let's implement our pop method. So same as before, stack.prototype.pop is going to be a function. So we want to save our variable or the element to a variable, and that's going to be this .store at index, which is represented by top, and -1 because we want the last one. And let's return our element here. And we want to delete the last element because that was popped out of the stack. So that's going to be this .store, this .top -1, and we want to decrement the length by 1, which is represented by top. Now let's test our code. Let's console log because we are returning something. Stack.pop. It should give us 3, and it should give us 2, 1, and undefined. So it looks good. Let's console log our stack here, and you can see that we have nothing, and our top became 1. But if you were to just get rid of this, it's looking good. So we can actually have a check here in our function to do, if it is a case that there is no elements, just stop. Don't even decrement the top. So let's actually try implementing that right now, just for fun. So we keep a if statement. So if this .top, if that's 0, we just want to return, just stop the function. So let's check if that worked. And you can see that it's returning undefined, and our top didn't decrease. Now let's implement our next method, which is peek. And peek is just simply going to return the element on the top of the stack. We're not going to remove it. We're not going to do anything with it. We just want to see what value it is. So it's going to be stack.prototype. And as you can see, it's just such a hassle to keep typing prototype and then set it equal to a function. If you're doing this many times, it would take really long. So if you were to use classes, that's going to save us some time. And it's actually clear to read because we wouldn't have different lines with stack.prototype all over the place. So we want to return simply the last element. So that's going to be this .store at this .top -1. And let's test our code, and let's uncomment these. So console log stack dot, it was peek, and that should give us 3. Okay, that looks good. And as you can see here, as we are adding more methods, we have push, pop, and peek under this stack object. Now let's implement our method where we check if the stack is empty or not, and then we're gonna return a Boolean value. So again, stack.prototype.isEmpty, set this equal to a function, and we just return. Well, if it's empty, that means that our top is going to be 0, right? So we do just exclamation with this .top. And if it's empty, it's going to return true. Now let's test our code. So console log stack dot is empty. So that should return false. So So you can see that it returned false. And if we were to just remove everything, that should give us true because our store and top is empty now. Now let's create a function where we just simply return the size of the stack. So same as before, stack.prototype size, and that's going to be a function. And we just simply return this .top, which represents the size of our stack. Now let's test our code. Same as before, let's console log stack.size, and that should return 3. Okay, that looks good. And if you were to remove some elements, now 2, 1, and 0. Now let's implement our clear method where it removes all the elements in our stack. So it's going to be called stack prototype and clear equal to a function. And we simply just reset store to an empty object and top to 0. And if you were to test this out, .clear, you see that our store and our top became empty. So store is empty object, top is 0 now. So if you were to uncomment that, you can see that we have our elements. Now let's implement our print method where we print all elements in the stack. So that's going to be, again, stack.prototype.print, set this equal to a function, and let's create a for loop. So for let I is equal to 0, I is less than this .top, and we increment by 1 each time. So each time we want to just console log this .store at index I. And let's try running our function. So if you were to just do stack.print, you can see that it's printing all the elements. So 1, 2, and 3 over here. Now let's just go over our time complexity just one more time. Well, access is going to be O of 1 because if we know the index of our element, we get our value at O of 1 time. So access is cheap. Well, search is going to be expensive because we will have to traverse through our array or object to find the element or the value that we want. And insertion and deletion for stack is of 1 because we are only concerned about adding and deleting at the end of the stack only. And that's what the definition of stack is. It follows a last in and first out principle. So we insert it at the top and delete at the top only. Well, space complexity is going to be O of n because that's going to depend on the size of the input. Again, so it depends on the elements that we put in. Now, what we did here different from our first array implementation is that we used object constructor function instead of class methods, but this is essentially doing same thing as classes. So if you remember, we did something like class, array, constructor function, and then gave our values or our properties. This is actually doing the same thing as giving properties of store and top, which is set to object, empty object, and 0. Now here, we were adding our methods to our stacked prototype. And if you remember, if you were to console log just stack.prototype, you will see all the methods that we implemented. So we implemented all these methods, but let's look at our prototype. We created a new instance of stack using new stack. And if you were to console log that, we have our empty object with the top variable or top property. And if you were to just console log stack.prototype, you see all the methods that we implemented. So this stack would have a access to all these methods. Now that's it for stack. I know that we went pretty fast, but again, we actually went over all this before in the array implementation video. So if this kind of confuses you, I definitely recommend you to start with that. Later, we are actually going to implement our stack using singly linked lists. So that's going to be a lot harder than this. But before doing that, I wanted to get a better understanding of how stacks work so that it wouldn't confuse us later. If you guys find this helpful, make sure you guys like and subscribe. Thanks.